There's this incredible, invisible force all around us. You can't see it, or taste it, or smell it, but it has the power to move huge pieces of metal, and get this, it even protects our entire planet. Today, we're going to pull back the curtain on one of the most fundamental and honestly coolest forces in the universe.
I mean, really think about it. Why does it just clamp on to that metal door with so much strength, but if you move it an inch over to the plastic handle, it does absolutely nothing?
And how in the world does that tiny little needle inside a compass just know which way is north? It doesn't matter where you are, in a deep forest or the middle of a city, it just works. How?
I mean, what is that amazing, unseen power that can reach across empty space and just pull an object right to it? It's like having a superpower, right? Well, it's not magic, and it's not a superpower. The single answer to all of these questions is magnetism. And over the next few minutes, we're going to see exactly how this incredible force really works.
All right, so let's jump right in and start with the basics. What exactly is this force we're talking about?
Okay, so at its heart, magnetism is a fundamental force of nature, just like gravity. It's created by things we call magnets, and it's a non-contact force, which is just a fancy way of saying it can affect things from a distance.
But here's the first real clue to the mystery. This force is, well, it's picky. It only interacts with a very specific club of materials. Your fridge door is made of steel, which has iron in it, so it gets pulled right in. But your wooden table or a plastic bottle, to a magnet, they might as well be invisible.
And this is actually something you can investigate right now. Just grab any magnet, and you can be a scientist. A paperclip will literally leap towards it, but a plastic spoon won't even budge. You're sorting the world into magnetic and non-magnetic, right there at your desk.
Okay, so we know magnetism affects some things, but not others. But what about the magnet itself? How does it work? Well, to understand that, we need to look at its two ends, which follow a single unbreakable rule.
These ends are called poles. One is the North Pole, and the other is the South Pole. And here's the really crucial part. You can never have one without the other. If you cut a magnet in half, you don't get a separate north and south piece. Nope, you just get two brand new, smaller magnets, and each one has its own north and south pole. And these poles obey the one fundamental law of magnetism, the rule that really governs everything. It's simple. Opposites attract. A north and a south pole will always pull together. But like poles repel. So if you put two norths or two souths near each other, they will always push each other away. If you have two magnets, you can actually feel this law in your own hands. Seriously, try pushing two north poles toward each other. You'll feel this bizarre, invisible cushion pushing back. It's so weird. Then, just flip one of the magnets around and, snap, you'll feel them leap together. It's an amazing way to physically experience this force. So, we know magnets can push and pull without touching anything. But how? I mean, what's going on in that empty space between them that lets them do that? Well, the secret is something we can't see, but it fills all the space around a magnet, basically creating its own little sphere of influence. It's called the magnetic field. A good way to think of it is like an invisible web of energy. Lines of this force flow out from the magnet's north pole, they loop all the way around through space, and then they go back in at the south pole, creating this complete, powerful circuit. Anything that enters this field is going to feel the force.
And what's so incredible is that we can actually make this invisible field visible. If you sprinkle tiny little iron filings on a piece of paper and put a magnet underneath, they'll magically snap into formation, tracing the exact shape of those field lines. You're literally seeing the architecture of an invisible force. How cool is that?
Okay, now let's take this whole idea and scale it way up, because the most important magnet in your life isn't the one on your fridge, it's the one you're standing on right this second.
Believe it or not, our planet Earth is one gigantic magnet. Deep down in its center, there's a spinning ball of molten iron and nickel that's churning away, acting like a massive generator. And this creates an enormous magnetic field that wraps around our entire world. It's not just for show, either. It's a life-saving shield that deflects a constant storm of dangerous radiation from the sun.
And that planetary field is what brings us all the way back to the compass. The needle inside is just a tiny, lightweight magnet. And remember how opposites attract? Well, its north pole is constantly being pulled toward Earth's magnetic south pole, which just so happens to be located very close to our geographic north pole. And that's it. That's why it's our unfailing guide, always pointing us north.
But hang on, the story doesn't end there, because magnetism has a partner.
kind of like a twin force that it's deeply connected to, electricity. And when these two get together, they literally change the world.
So about 200 years ago, a scientist named Hans Christian Ørsted discovered, almost by accident, that an electric current flowing through a simple wire creates its very own magnetic field. This incredible link, which we call electromagnetism, is honestly one of the most important discoveries in all of human history.
And you can build one. Just wrap a wire around an iron nail, connect it to a battery, and boom! That nail is now a magnet. It'll pick up paper clips. But here's the really game-changing part. Disconnect the battery, and the magnetism just vanishes. You've created a magnet that has an on and off switch.
So, why does all of this matter? Because that simple on and off ability of an electromagnet? Well, it's not just a cool party trick. It is the absolute bedrock of our entire modern world.
Just think about it for a second. The electric motors in our cars and blenders, the speakers that push out sound waves, the computer hard drives storing all our data, those massive cranes in scrapyards lifting tons of steel, the MRI machines that can see inside the human body, even mind-blowing maglev trains that float on air. It's all powered by the exact same principle you just saw with a nail in a battery.
So, the next time you casually stick a magnet on your fridge, just pause for a second. You're not just playing with a simple chunk of metal. You are tapping into one of the fundamental, invisible forces that built our planet, that protects all life on it, and that powers our entire civilization. Pretty mind-blowing, isn't it?